Hello everyone, this is Don with MecSoft Support. I wanted to create a short video talking about the use of 2.5 axis profiling versus 2.5 axis engraving and when to use each. Basically, in profiling, the diameter of the tool is compensated for when defining the tool path. So for example, if you want a tool, uh, you want the tool to follow a pocketing area, like you're profiling around the outside of a pocket, uh, the tool diameter will lie on the geometry and the tool path itself will be at the center of the tool. But in many cases, users want the tool to actually follow the geometry. In other words, not compensate for the tool diameter. So in this case, you would want to use 2.5 axis engraving. Now, engraving is a very versatile operation. It doesn't just follow a two-dimensional curve. In 2.5 axis engraving, the tool will follow any curve. It can be a three-dimensional curve. Anywhere that curve goes, the tip of the tool will follow it. So let's show you how each of those are used. So what I have on the screen is some two-dimensional geometry. And what I'm going to do first is I'm just going to select it all and merge it. Let's get rid of that first and get rid of that. And then I'm going to merge these together. Okay, so got one curve. Now, let's start with a 2.5 axis profiling operation. So we're going to go 2.5 axis profiling. We're going to, for our control geometry, we're going to select this curve. And then for a tool, we're going to create a 1/2 inch flat mill. Save that as a new tool. And for the cut parameters, we're just going to run leave the default parameters. We're not too picky about what the parameters are. I want you to see how the tool follows the control geometry curve. So for the cut levels, we'll just leave it at top and we'll go down to say 1/2 inch. Okay. Entry and exit, we just do none for now. Okay, we can do some arc fitting. Okay, let's just generate that. So what you see here is, let's go ahead and make the tool path a little bit easier to see. Okay, so what you see here is the actual tool path is inside of the curve. The tool geometry diameter is compensated for. So let's go ahead and run the tool across that so you can see exactly where it's going. So you see the tool there, it's starting here, and it's following around. So if you look over here, the tool diameter is compensated for. It follows the curve around. Now, what if you want the tool to actually follow the curve, the tip of the tool to follow the curve? That's where you would be easier to use an engraving operation. You could do it with profiling by adjusting the stock to move it over, but that's you don't need to trick the program into thinking just to move the tool onto the curve. So let's go ahead and we're going to go 2 axis and we're going to go engraving, and we're going to use the same curve. Okay, we're going to use the same tool, and we're going to, for the cut parameters, everything's going to be the same. We're going to cut down 1/2 inch. Okay, and we will do none for the entry and exit, just like the profiling. And we're going to do some arc fitting. and generate. Now for this, you see that the toolpath is actually on the geometry. If I turn off the toolpath, you'll see, okay, that the engraving path followed the geometry. And let's see what the tool cutter looks like. So we're starting in one of the corners and it's just going around following the tool, the control geometry curves. So what does both of these look like in simulation? Let's go ahead and do that. So let's go ahead and create some stock. And we will do 1 inch deep. Okay. And let's turn the stock on. We'll go to an isometric view and we'll align the stock. We're going to align it to the top. Pick OK. So there's our curve. And let's go ahead and simulate this. Slow that down. Okay, so there's our cut, and let's see what the part, turn the part on. So you see that here's the curve, and the tool just followed the curve. The outer diameter of the tool followed the curve, just like in a pocketing. It's profiling around. Now let's do the engraving so you can see how that looks. Let's move that up, and let's run that. So with engraving, the tool actually, the tip of the tool actually followed the geometry itself. So this is a very, very versatile operation. We have users where they want minute control, exact control of where that tool goes. So they just draw the path. They draw the curves exactly where they want the tool to go. Use the engraving and it'll start at that curve and it'll stop at the end of that curve. And you can give it some depth, whatever depth that you wanted to use, and it'll also follow a three-dimensional curve. So let's just create a three-dimensional curve. Just while I'm here, I'll go ahead and do that. So we will go curve, and then we will go a polyline. Let's just do a freeform curve, do control points. So we're just going to start somewhere up here and we're going to go somewhere down. Let's turn ortho off. So we're going to do a curve, doesn't matter what it is. So let's just do that. Okay, so we got this weird funky curve. Okay. It's not a two-dimensional curve. So now let's just do the same operation and let's apply it to this curve. Let's remove all, select our curve, generate. So you'll see the tool actually follows the curve wherever it goes. And we're just going to see the curve, the tool, it's just going to follow that three-dimensional curve all the way down. Okay, so this is very, very versatile. We've had users even draw a curve and do an engraving just to get the tool over to a certain point after a certain cut. Okay, let's say you don't want it to return all the way to the tool change point. Let's say you just want it to move to a certain location. Just draw you a curve, do an engraving operation, and the tool will move to the end of that curve and stop. Okay, I hope you found this useful. Take care.